Once again, a very good morning to one and all. So in last session, we just created a full adder that was adding two bits and one carry from the previous stage, or the initial carry was taken into consideration. And in today's session, we are going to design a parallel binary adder. Okay, we are going to design a parallel binary adder. Okay, so how does this work? This is nothing but a combination of two or more full adders, okay, in cascade configuration. Okay, what does this cascade means? Cascade means one after one, or in sequence. Okay, so let us see. General structure of parallel binary adder is somewhat like this. So you have got a say you want to perform 2-bit operation. Okay, so what you will do, you will take two full adders, okay, fa2 and fa1, and will make some connections between these to get the final output. Okay, so let us see these connections with the help of an example. Suppose you want to do binary addition, that is 0 1 0 and 1 0 1. Okay, you want to perform this. Okay, so how this is done is, first you will add 0 and 1. Okay, and as we are using full adder, so the initial carry is not given, so it will be assumed as 0. Okay, so the output will be 1, with next carry moving to next stage as 0. Then the output of the sum bit will be 0 plus 1 plus 0 will be 1. Carry move will be 0, and the output again will be 1, with the final carry as 0. Okay, or to more clearly understand it, let us take triple 1 plus 0 1 1. Okay, with the initial carry of 0. Okay, initial carry is what? 0. So summation for this combination will be 1 plus 1 is 2 and plus 0 is 2. So 2 will be written as 0 and 1 of carry. Okay, so this, the carry of this is moved here. Then 1 plus 1 plus 1, this will be performed as 1 plus 1 plus 1 equals to 3, which is equals to 1 1. So we will write this one, we will write here, and this one of the carry will be moved to next stage. So this will be like 1. Again, perform the addition, you will get 0 and a carry of 1. Okay, so in this manner it is done. So let us do this in let us do this in Logisim. So where's the Logisim here? Okay, so for this Logisim, for this application, first we have to get a full adder and then use it to make multiple full adders in the same circuit. Okay, so first let me open the full adder circuit that we have designed in a previous session. Okay, so I will just open this, open, control A. I will just copy this and close this. Oh, now this is my fresh file. I will just right click here, or I can just take from here, add circuit, name it FA, and put a control C, and I will just paste it here. Okay, so what I have done, I have just in this design of the main. Okay, this is my fresh scale. Let me first save it as control as. This is my parallel binary adder, and I'm making it for say 2 bit 2 bit parallel binary adder. Okay, so this is my main file. This here I have to make that connection of multiple full adders. But first let me create a full adder. Okay, so this is the circuit of my full adder. Okay, so now to make it as a sub circuit, what I can do, I will just click here. This will help me to design a block diagram of this circuit. Okay, so I will just click here. You can see. Okay, I will just stretch it. Say I just want to keep it this much. Okay, I will place the outputs here at the bottom side, inputs at the top side. Okay, this is my circuit diagram. Okay, so I will just come back here. I will just go back to my main main panel. Take this full adder that I have designed. You can see we have 3 inputs on the top and 2 inputs at the 2 outputs at the bottom. I can also name these. Just for that, I have to again go to full adder. This circuit, its circuit appearance, and then I would have to write here. I can use this tool, and I can write here like what is this? This is for my, I think this was my some carry bit. Okay, so I will just write here. This is what carry or carry out. This is my sum out. This is, let me check what these are for. This is my okay A and B. You can see here highlighted. You can see at the bottom of the screen here. As I click on it, that particular pin will be highlighted. Okay, like some. Okay, and the carry. So I will just name it as here. This is my A. This is my B, and then this is my C, and here you can write like full adder. So this is full adder sub circuit. Okay, and this I can move to the center like this, and this also I will move to the. Okay, again I will come to main. You can say that corresponding changes has been are being reflected on the main panel. Okay, I will just name it as, this is my full adder. Say as we are performing 2-bit operation, so I will just name it fa1 and make it north facing. Okay, let me move it here. Then again I will take, I will just select it, copy it, and paste it here. Okay, so this will be my full adder 2. Then I can also change the font like this. I will just go to here and make this 26. Okay. Okay, so these are my two full headers. Okay, so now what I have to do, I have to take the bits, you know. So let me take this was 2-bit operation. So let me take it as mm, uh, let me take uh, mm, okay, let me take simply these. Okay, so this, let me place them here. Okay, and make them all as bottom at the south. Okay, so this is for A, B. B. Let me rename this, these as, say this is my E1, or you can just simply select this and right here also E1. This is your E1. This is your A0. This is your 0. The nomenclature that I'm using is the most common that you can find in your textbooks. And for this, let me say this is C0, and as this is the initial full header, so it will always be connected to the ground if not specified. So let me assume for this instance initial carry is always 0. Okay, so I will just come here and I will take a ground, place it here, and connect this to ground. Okay, then this sum will give me the output. Okay, so let me connect this LED should be upward facing. Okay, so I will connect this LED. Similarly, I will take one more LED and connect to this. This carry will be moved on to the next part of the circuit. So I will just make these wires like this, and this carry out will be the final carry. Okay, so I will again connect one LED here, make it northward connection, and connect like this. Okay, so this is my uh, this is what my carry out carry out. This is my sum one. This is my sum bit 0. Okay, so we have made the connections of full adder. Okay, now let us see if I'm going to add okay, so these two examples we have taken. Okay, let us take some Okay, let us take some 2-bit examples. Say we want to add 0 0 and 1 0. Okay, so the output of this operation will be 0 1 with a carry of 0. And if we want to add 0 1 with 1 1, okay, so the output will be 0 with a carry of 1, 0 with a carry of 1. Okay, so let us check these conditions. So the first case is 0 0 and 1 0. Okay, so this is 0 and 0, and next case was for the B, it was 1 0. So it was 1 and 0, and the output is, you can see the output is carry bit is 0 and the output is 1 0. See here, carry bit is 0, output is 1 0. Okay, and for next example, that was 0 1 and 1 1. So 0 1, and this is 1 and 1. Okay, you can see now the carry is being propagated to the next full adder from the first to second full adder. Okay, so the output is 1 0 and 0. Let us see numerical. Okay, correct, 1 0 and 0. So this circuit of ours is completed. Okay, so what we have done in this circuit is we have made a full adder. This one we have edited its circuit appearance, and then use that full adder as a sub circuit for our design, because it would not be possible to make uh, this kind of circuit for multiple bit. It will be too much confusing, too much bias, too much connections, and too much outputs, everything too much. So that's why we have designed a sub circuit and we have used it in main circuit for this purpose. Okay, so this is all for this session. In next session we will be seeing that binary to gray code converter. Okay, we will be seeing binary to gray code converter, how to design a binary to gray code converter. Okay, so let me close it. This is no, okay, sorry, first I have to export its file. Save, this is already done. I have to export it. So prior to that, let me write my name. See, the thing I'm doing, saving, exporting, it is not necessary on my part, because I do not have to prepare a file. You people have to do that, but it is just a good habit, good practice to do that. Okay, so for further record keepings. So if you happen to work on these tools where you do not actually have to present some evidence of your work, then also it is recommended on my from my side that you always make things as proper as possible. Okay, so where should I write? uh, let me move these a bit far. Okay, so I can get the space. Okay, I think this much is space is sufficient. Okay, here I will write. Okay, so why I'm writing this in the middle of circuit, I have already explained during first session, so that no one can copy your work. It's just simple as that. So keep in mind in these short tricks, and try to design your own circuits. Okay, so see you next session with binary to gray code converter. And prior to that, let me export that image also. Both I am exporting. So this is my parallelly binary adder with FA, or let it be parallel binary adder for 2 bit. operation export. Let me check it out, how it has came out. Okay, so because of the subcircuit, it has created its own folder. Okay, nice feature of this tool. And this is your FA, and this one is your, okay, main circuit diagram. Okay, so you can just prepare the files likewise. You don't have to keep in mind which figure to pick or not. It automatically does that for you. Okay, see you in next session then.